With these keys, we're almost ready to communicate over TLS. There's still one last step to finish up the handshake. So the client has all of the keys that are used for sending or receiving from the server, and the same for the server. The client, as it's next to the last part of the handshake, is going to send using the key that it always uses to encrypt now for the server. In this session, it's going to compute a hash of all the history so far using the key that it uses for max. And this last step of the TLS handshake is going to protect against a ground grade attack. So we're making sure that the client and server agree on the history. In particular, we make sure that all of these cipher suites that the client offered were available for the server to pick from. A man in the middle could try to attack this with a downgrade attack by removing the strongest of those cipher suites and keeping only the weakest to try to make it easier to break into the communication between the server and the client. That's called a downgrade attack, and by including all of the history so far, we make sure that doesn't happen. And the server responds back, again with its extended history. So this step should look familiar. We did it already in the client authenticated case, but if we are not in client authenticated mode, then this finishes up that connection between the client and server and makes sure they agree, and so we need it for both of those modes. If you're looking at the protocol, these last bits of the handshake are tagged as change cipher spec instead of handshake. So they're not actually changing the cipher that they've chosen, but that is the tag that's used on this last bit of the message. So if you see that in Wireshark, then you will know that that's the end of the handshake.